In the next exercise, we're going to introduce the concept of a probability tree. Now, it's really important that you realise this is not a tree diagram. In its structure, as you can see here, it's similar to a tree diagram. However, it does have some really significant differences, and you need to be aware of those. The great advantage of a probability tree is that it's very much refined. It doesn't get as cumbersome as a normal tree diagram. The disadvantages are that you lose detail. You lose a lot of information. You know, with your tree diagram, the most valuable part of it is being able to list all the possible outcomes. That will not be the case now with a probability tree. You won't list every single outcome. You won't be able to see all possible results. So that's the disadvantage. However, the advantages of the probability tree, I think, far outweigh the disadvantages, and you get to probably rely more on probability trees than you will a tree diagram. In the construction of the probability tree, you're going to use the addition rule, which we haven't spoken about, as well as the multiplication rule that we just introduced in the previous video. Another key feature of a probability tree is you must write the probability on your branch. So you can see that written here. And I'll explain where the 3 on 7 comes from when we get to this. You must write your probability on each branch because no longer are every branch equal in terms of their probability. And again, that will become more obvious when we talk about an example. So we've said, yes, we're going to use the product rule because we're going to be multiplying along our branches. And then if we want more than one branch, we want something or one situation or another situation, then that's when we use the addition rule. So the key word in this case is the or, and we learn to associate the or with adding probabilities. Let's have a look at this example. A bowl contains 3 red and 4 green apples. Jane's going to select 2 apples at random from the bowl. So our headings are first choice and second choice, because we want as our possible outcomes what the 2 pieces, the 2 apples are going to look like. Now, normally in a tree diagram, we would have, since we have 7 apples, we would start off with 7 branches. So I'm sure you can see that 7 branches, 3 of them we would put red on, and the other 4 we would put green on. And already you can see that it's getting too big. So what we do is we reduce our branches to either red or green. So we're covering all possibilities. The apples are either red or they're green. However, like I said, these branches are not equal. The probabilities of each branch is not the same. You can see that there are fewer red apples. So the probability of getting a red is only 3 in 7. Whereas with 4 green, more green, there's a bigger probability of getting a green. So we put our 4 on 7 in there. With our first choice having been made, we consider our second choice. Now, if it is possible to select another red apple, we would have a branch indicating red, and in this case you can. And it is also then possible to select a green apple. Now note the change in the probability. there's a change now of the probability of getting a red apple is only 2 in 6. After one red apple has been removed, there are only 2 and red apples left. There are only 6 apples. The probability of the green apple, well, all 4 green are still there, and so it stays 4 in 6. Interesting fact to note is that the probabilities on your branches should always add to give 1, because you're covering all options. And likewise back here, the probability 3 on 7 plus 4 on 7 is 7 on 7, which is 1. We're covering all options. Our probabilities add to give 1. Let's consider the second option for the second choice, and that follows after a green apple has been selected first. So after that, is it possible that a red apple could be withdrawn? Of course it is. There are still all 3 there, 3 red apples. However, there's only a total of 6 apples. So the probability of a red is 3 in 6. Is it possible to get a green? Of course it is. There were originally 4. 1 is gone. There are still 3 left. Now you would probably choose to write that 3 on 6 is a half and a half. And of course, again, you can see that your probabilities here add to give 1. We continue on to write the possible outcomes. However, it doesn't cover every single individual outcome. But you can see that a possibility is a red and a red, 2 red apples, or a red followed by a green, or the first apple may have been green, second apple red, or the first apple green and the second apple green. The probabilities of these outcomes, the probability of getting a red followed by a red, so we've got red and red, we multiply. Red and red. So it's 3 in 7 times 2 in 6. 2 in 6 is 1 in 3. 3's gone. And we've got 1 in 7. Probability of a red followed by a green. I'll just pause the video and fill these out. So you can see that I have multiplied these probabilities along the branch, red followed by green. So we want a red and a green. Multiplying, we get 2 in 7. Likewise, the probability of a green and a red is along the green branch is 4 in 7. Along the red branch is your 3 in 6 or 1 in 2. And cancelling down, you get 2 in 7. Finally, the probability of a green followed by a green is your 4 in 7 times a half, which is 2 in 7. You might be wondering where the addition rule comes in. Well, if I was to consider all the options, then I would have the probability of a red, or the probability of a red followed by a green, or the probability of a green followed by a red, or the probability of a green followed by a green. I know I've covered all options. My probabilities should be 1. And let's just check that they are. 1 in 7 plus a 2 in 7 gives 3 in 7. Another 2 is 5 in 7. And another 2 is 7 in 7. I've covered all probabilities and possibilities, and you can see that, again, the probabilities add to give 1. Some rules to remember is to find the probability of a particular outcome, multiply the probabilities across the branch. Then in general, if you hear yourself saying and, then you multiply. I definitely want this and that. Whereas if you say, I want this situation or this situation, then you will add. Or is an add. I'll leave the video here and I will complete the examples, but I won't do videos on them.